Beams and frames. Determinacy describes the complexity of analysis to determine the reaction. So we actually have two types of determinacy. So number one here is what we call the statically determinate structure, and the other one is statically indeterminate structure. Now, what is the difference between these two? So if you say statically determinate, this one is the equilibrium equations provide both the necessary and sufficient condition for equilibrium when all the forces in a structure can be determined strictly from these equations. So, ibig sabihin, if you say it is a statically determinate structure, it can only use summation forces vertical, summation forces horizontal, and summation moment alone, you can already solve for the reactions. Say, for example, you have a simply supported beam. So, pag simply supported beam, how many reactions do you have? So, you have 1, 2, 3. So, you have a 3 reactions. Then you have 3 equations. So therefore, you can solve for the reaction because you have 3 unknowns, 3 equations. Now, what would happen if I say this one is a hinge also? So how many reactions do you have here? You will have 4 reactions. But again, you have you only have 3 reactions. So 4 unknowns, 3 equations, is that sufficient? So no. So ang ibig sabihin nito, if you cannot use the 3 equation or it's not enough, the 3 equation, your structure would be statically indeterminate. So hindi kaya ng equations of equilibrium alone na isolve yung reaction. So, yun yung difference ng statically determinate and statically indeterminate structures. So, yun lang siya. So, ibig sabihin, if your structure is statically indeterminate, you have redundant reaction. So, parang madami kang reaction. So, that is the sense of determinacy. So, we actually have two parts in this subject. We have the analysis of statically determinate structure, and later part of your course, we will discuss the statically indeterminate structure. Now, how would we know if our structure is determinate or indeterminate? So we can use this equation, R and 3N. Just have to compare these two values. So yung R natin and yung 3N. So your R is the number of reactions. Then your 3N here, your N is the number of members. Then we also have your I. So yung I nyo, this one is the degree of indeterminacy or the number of redundant reaction. Redundant reactions. Ayan. So, yung I natin, this one is only for statically indeterminate. Now, pag yung R and 3N nyo are equal, you can say that your structure is statically determinate. It is greater than, therefore it is statically indeterminate. Now, if it is less than, so therefore it is unstable. Yung I natin, you just have to subtract R and 3N. So, later on, pag may examples, mas maintindihan nyo siya. Say, for example, here, we have your beam here. Okay, so we have to determine the R, number of reaction, and 3N. How many reactions do we have in this particular beam? So, we have hinge here. So, ilan ng reaction? So, we have 1 and 2. Now, then roller, you have 1. So, all in all, you have 3 reactions. Then, how many members? You only have 1, which is that one. So, 3 times 1. 3 and 3, this one is equal. For this beam is statically determinate. So, ibig sabihin, you can use the 3 equations of equilibrium, summation forces vertical, summation forces horizontal, and summation moment. You can use these 3 equations in answering the reactions here. So, how about here? R and 3M. So, how many reactions? So, this is a fixed reaction. So 1, 2, then 3, then you have roller, then roller. So all in all, you have 5 reaction. Then 3 times how many member? You only have 1 member here. So 1. So 5 and 3, 5 is clearly greater than. So therefore, this one, it is statically indeterminate. Using these 3 equation is not enough. So how many redundant reactions do you have here? You just have to subtract 5 and 3. So 5 minus 3, you have 2 redundant reaction. But this one, we use it in terms of degrees. Kaya siya, it is statically indeterminate, second degree of indeterminacy. Okay? Then another. Here, we have here a while ago, our past lecture. This one is we have a slider. So, ang slider, we have horizontal reaction and we only have moment. Now, how about this one? This is what we call your internal hinge. Now, ano ang internal hinge? Again, externally, it doesn't have a value, but internally, it would have a value. But we still have reaction here internally. But again, externally, we don't have. So, ito, binibilang pa rin natin siya as part of the reaction. Kasi reaction pa rin siya. So, we have 1, 2. So, bakit hindi 4? Pag gagawin mo siyang free body diagram, you would have this. Yan. Then you have, ito yung internal hinge, then that one. Then you have your hinge here again. Now we have your reaction here. Then we have here, this one's going upwards, therefore here going downwards. Then we have here, here, and here. So again, externally, it doesn't have a value. Kasi pag kinumbine mo, it should be equal to 0. Then you also have here this reaction. So again, here, externally, it should have, here, it doesn't have external reaction, but internally, again, it has. So, bakit hindi 4 ang bilang natin? Because, in theory, you only have 2 reactions. So, we have only this one, yung vertical, and we have the horizontal reactions. So, yung ano lang natin dito, yung directions lang kasi natin dito, kaya siya nagiging 4. Para externally, it would become 0. But if you are counting reactions, you only have 2. You have the horizontal and you have the vertical. So therefore, ang bilang lang pag internal hinge is only 2. So all in all, you have 1, 2, 3, 4. Then you have hinge here, 5, and 6. So our reaction is 6 and 3 N. So, how many beams do we have here? Again, may internal hinge na tayo. So, mapaghihiwalay natin yung members. All in all, we have 2 beams. So, which is this one and this one. So, 1, 2 members. So, you have 6 and this one is also 6. So, equal. Therefore, this one, it is statically determinate. All right. How about here? So again, we have 3 reactions. So again, we have R reactions and 3N. So R, how many reactions? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 reactions. Now, how many members? 3 times. How many members? I have 1, 2, 3 members. So times 3. 10 times 3 times 3, you will have 9. So it is greater than. Therefore, this one, it is statically indeterminate. In how many degrees? So 10 minus 9, you will get first degree. Okay? Another, you have here, how many reactions? So we have 1, 2, 3, 4, 5, 6, 7. So we have 7 reactions. Now, how many members? We only have 2. So 1, 2 members. So 7, 6 greater than this one it is statically indeterminate. In what degree again? So 7 minus 6, that would be 1. So first degree. Okay, so how about here? So again, 3R and 3N. So again, R and 3N. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 reactions. 3 times how many members? So you have 1, 2, 3 members. So 9, and then this one is also 9 equal. So therefore, this one it is statically determinate. Okay, so another. So we have how many reactions? So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 reactions. So how about 3N? So 3 times how many members? Is just 1 member and all of this is 2 members. Kasi ito lang yung hinge natin, internal hinge. Again, we only have 2 members here. Okay? We have here 10 times 6. So greater than, again, this one, it is statically indeterminate. In what degree? So 10 minus 6, that would be in 4th degree. So another, we have here your link. So we only have 1 reaction here. So kung hindi nyo ma-remember, you can just go back to our previous lesson. We only have 1 reaction here. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. So reactions, you have 9 reactions here. Then 3 times n. So how many members do we have here? So we only have 1, 2, 3. So again, 1, 2, 3 members. So 9, 9 equals. So therefore, this one, it is statically determinate. Alright, so how about here? We have a frame here, this one. So if you see here, you have a closed loop. This is what we call your closed loop. Yan, which is this one. Ito, this one is what we call your closed loop. Ang gagawin dito, you have to cut your frame. So pag kinat natin yung frame, so we will have this free body diagram. And kinat natin siya. So how many reactions would you have here? Now take note, if you have here a beam, it could carry what? You have your shear and we have the moment, correct? Then we have your thrust. Your thrust can only carry axial forces. Then we have the frame. So ang frame natin could carry shear, axial, and moment. Yan. So, pag hinati ko yung frame natin, meron tayong shear, we have the axial, and we have the moment. Also here, we have your shear, you have your axial, and your moment. So, all in all, ilan yung magiging reaction natin? So, we have hinge here. So, 1, 2, 3 roller. Then, plus this one. So, 3, 4, 5, 6, 7, 8, 9. So, you have 9 reactions. Then we have 3n. So how about the 3n? 3 times how many members na? So again, hinati natin siya. So this would be 1 member, then 2 members. So times 2. So we will have 9, then 6. So it is greater than. So therefore, it is statically indeterminate. In what degree? So 9 minus 6, that would be 3. So degree, third degree indeterminate. Degree of indeterminacy. So 3 degree. So third degree of indeterminacy. Ayan. So you have to take note. If you see a closed loop in frames, you have to half it or you have to cut it in sections. Now, how about here? So again, we have your closed loop here. So ika-cut natin here and here. Ayan. So we will have your equation. So R and 3n. So we will have how many reactions? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 reactions. Then how many members? So we have 1, 2, and 3. So we have 3 members. So 18, then 9. So therefore, that's greater than. So therefore, it is statically indeterminate. In what degree? So 18 minus 9, that would be 9. So ninth degree indeterminacy. Ninth degree. Okay? So we can also say that tanggalin natin to. So dito lang natin siya ikakat. Will you still get the same answer? So let's try. So how many R's do we have here? So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you have 15 reactions. Then how many members do we have here? So we have first member, then you have your second member here. So 3 times 2. Sorry, this should be 3n. 3n. So 15 and 6. So greater than, it is statically indeterminate. In what degree? So we have 15 minus 6, you will still get 9. Okay, so again, yung cut section natin, it is only for closed loop. So here, kung makikita nyo, wala naman tayong closed loop here. Kaya it is okay for you not to cut this section. But if you cut this, you will still arrive with the same answer. So either which, it is okay. You will still arrive with the same answer. Okay, so another is you have here this one. So we have how many reactions? So we have 1, 2, 3 reactions. So 3 reaction, then 3n. So how many members? 1. So 3 is equal to 3. So therefore, this one, it is statically determinate. But wait, there are times that say sa equation natin, you arrive with the answer that it is stable, na statically determinate siya. But in reality, this one is actually unstable. So why is that? Because this one is a concurrent reaction. You have a concurrent reaction. So what is a concurrent reaction? So if you say a concurrent reaction, your reaction here or yung line of action of our reactions meet at a point. Say for example, this one. Ayan. Yung reactions natin, nag-meet sila in one point. Ayan, yung line of action natin. So what would happen kung ganito yung nangyari? The tendency if you have a concurrent reaction, magiging unstable siya. So, take note here. Maglalagay ako ng load dito. What would happen? Then, ano to? Roller, roller. There would be a tendency na parang gaganon siya, nag-glide yung structure natin. So, pag nag-glide siya, therefore, our beam or our structure here is unstable. So again, if you have a concurrent reaction, you don't need to solve it already. Automatic, you can say that the structure is unstable. Okay? So how about here? So here, we have your roller, roller, roller. Again, how many reactions do we have here? We have 3. Then 3n. 3 times how many member? You only have 1. So 3 is equal to 3. So therefore, this one, it is statically determinate. But again, this one is also unstable. Although you say, sa equation natin, lumabas siya, it is statically determinate, it is also unstable. So why is that? Because we have here what we call parallel reaction. Okay, so pag sinabi mong parallel reaction kasi, you don't have a horizontal or vertical resisting force. Now, say for example, ito, yung reaction natin, this one is all vertical. Vertical sila. Now, what would happen, say, pag naganito ko na load? So, pag ganito, you have a component na P vertical and P horizontal. Now, our structure here, wala tayong resisting force here para maging stable yung structure natin. Now, pag ito wala, there is a tendency that our structure here will slide. So, mawawala yung beam natin dito. Kasi again, this one is just roller. Okay? So, therefore, if you have parallel reaction, so lahat sila vertical or lahat sila horizontal, wala kang vertical or wala kang horizontal na reaction, you have what we call parallel reaction. Now, automatic, if you say parallel reaction, it is already unstable. You don't need to prove that ganito yung ano, you don't need to solve for the equations here. Basta pag nakita nyo, ganyan yung itsura, automatic it is unstable. Okay, so how about here? Is this a concurrent reaction? Actually, no. So, meron tayong, ayan, that one, and like that. So, we have here your components only. So, yung hinge natin, naka-components lang yung vertical and yung horizontal natin. We have a resultant in hinge. Now, say yung resultant natin somewhere here. Yan. So, i-extend natin siya. Then, this one, you have your roller. You have like that. Ayan. Nag-meet ba sila? No. The line of action of for this one is not a concurrent reaction. So, we can still say that this one is stable. So, R, how many reactions? So, you have 1, 2, 3 reactions. Then, 3 times 1, 3, equal pa rin siya. So, this structure is statically determinate. Okay, so how about here? You can say that it is already a concurrent reaction. So, because again, you have, ayan, then ito yung magiging resultant niya. So, hindi lang nag-meet in one line yung line of action nila. So, it overlaps the line of action. So, therefore, automatic, this one, it is unstable. Correct? because it has a concurrent reaction. Ayan, automatic. Have R and have 3N. So we have how many reactions? So you have 1, 2, 3, 4, 5, 6, 7. 7 reactions. Then 3 times N. So we have 1, 2, 3. 7 and 9. It is less than. For this one, it is unstable. Ayan. There are also times na minsan, lumalabas to statically determinate, statically indeterminate, but it is unstable. So, paano nangyayari yon? So, this one is what we actually call a collapse mechanism. Ito. This is what we call your collapse mechanism. So, what is a collapse mechanism? Now, imagine this one, hinge, hinge, hinge. Then, this one is a roller. Now, pag naglagay ako ng load dito, what would happen to the beam? Just looking at it, you can see na magko-collapse siya talaga. So, it is a hinge. So, probably, magaganyan yung structure nyo. So, this one is what we call your collapse mechanism. Pag dire-diretso na internal hinge, then hinge, hinge, ayan. So, that one is the collapse mechanism, no? This one is just a special case. Now, most of the time kasi may lumalabas na it is statically indeterminate, but it has what we call your collapse mechanism. So, you also have to observe yung mga structures natin to say na it is unstable, but pag sinolve natin, lalabas siya statically indeterminate. Okay? So, in summary, you only have 3 equations, your R and 3N. If it is equal, it is statically determinate. If it is greater than, it is statically indeterminate. And if it is less than, it is unstable. But we also have 3 types of special cases. You have concurrent reactions, you have parallel reactions, and lastly is collapse mechanism. It is automatic unstable.